Hey everyone, this is Cses and welcome to my channel Kurdisk. Let's solve the problem traffic lights. There is a street of length x whose positions are numbered from 0, 1, 2 up to x. This x would be given to us. So there is a street and there is a numbering done on the streets and x in our case is 6. Initially there are no traffic lights, but n sets of traffic lights are added to the street one after the other. So there is a no traffic light in the beginning. So the maximum length of the street is 6, right? The max length. The longest passage is 6 without the traffic light. Let's add a traffic light at position number 2. Now, we need to calculate the length of the longest passage without traffic light. So when we add this traffic light at position number 2, this addition of the traffic light now breaks the maximum length or the longest passage into two parts. First is this and the other one is this. So we get 6 minus 2, that is 4, and 2 minus 0, 2. So we get these new distances and we need to calculate the length of the longest passage without traffic light. So this is the length of the longest passage, which is 4. Now let's add one more at position number 5. Again, this is going to break into two parts and this was originally there. So now the length, the longest passage is no more this, which was 4 earlier. It is no more now. So the length of the longest passage is this, which is 3. So what we get from this? We get first distance. We are calculating the distance and we get also this, that whenever a new light is added, it breaks the original gap and it gives rise to two new distance. That is clear. Whenever a new light adds, it breaks the original distance. Let's see further. So for the next example, we will use x is 8. That means the length of the street would be 8 and there are n sets of light. That means there are 3 sets of the light which will be added at position number 3, 6 and 2, one after the other. Let's see. So we have the street represented in an array format, and as told earlier in the slide, we are going to require to calculate the distance, and distance is always calculated whenever we have the start and the end point. So when we subtract the end minus the we subtract from end and start, we get the distance. So we should have a start and end. But in our case, what should be the start and end? Clearly, since it is the beginning, we don't have any lights. So the max length is the complete street length, which is this. So we will have a container traffic lights which holds this this start and end, which is 0 and 8. And what should be the container, we will see later. And what is the distance currently when there is no traffic light? That is 8, right? So we add this, and this traffic light and distance are two containers. So we should get some idea that we have to require the distance. So we created a container which holds the distance, and we should have one container which holds the traffic lights. And since in the beginning there is no traffic light, so we added just the start and end. Now the traffic light has been added at position number 3. So this is going to break into two segments, the original distance. So this position traffic light at position number 3 has been added, and I should now calculate the distance, right? We should calculate the distance. Now we have this one start point and we should subtract it from here. We can see from here, but how should we get 8? Since in the traffic light we have 8, so how can we get this 8? And if you have watched my previous videos, you could have thought what should be the thing we should do here. If not, no problem, but I would suggest that if you watch my previous videos, which are towers playlist, there I have explained, and which I'm going to use the next thing, that is upper bound. It should be clear till now that we should use upper bound here, because when we do upper bound of 3 on traffic light, we get this 8. Upper bound, if you have any issue, then I have already made a video, just watch it and you will know how we use upper bound, why we use upper bound. So we are using upper bound, so that would give us the next higher element which has been passed. So the next higher element present in this container is 8. So we should use upper bound on 3, that will give us 8. And since now we are using upper bound, it has the container element should be sorted. Therefore, we should use some container which already sort the element in the already contains the element in sorted order. Therefore, we will use maybe set. So yes, that we can think that we should use set. Now upper bound of 3 is 8 when we did on this traffic light. Then we subtract to get this distance, that is 5. And upper bound of 3 is 8. Our iterator is pointing over here, right? The iterator is pointing over this element. Now if I decrease our iterator, we will jump to this, which is this side, the left side of the traffic light. So if we do 3 minus 0, we get this distance also. So, and yes, we have removed the max distance, which was 8 earlier, because this addition of traffic light breaks the original distance, which was 8. So we add 3 and then this 5 to this distance. So this is 3 distance, and this is the distance 5. We have this. And we should also insert this new traffic light in this traffic lights container. What would be the answer to this? Yes, the answer to this is the end position, or the last position of this distance container, which is 5. The last element, which is 5. So let's do a mind reversal, how we got all this. So we did upper bound. Why did we did upper bound? To get the next higher element on the traffic light. So we did upper bound. Then we also found that whenever a new light is added, it breaks the original gap and it gives rise to 2 new distance. Therefore, we should delete the previous distance. That means we should erase the previous distance. And then we should insert the 2 new distances which has been formed whenever the traffic light has been added. And then we display the last element, which is our answer. Let's apply the same thing. So here let's add one more traffic light at position number 6. So we added at position number 6. What is the upper bound of the 6? That was 8. So 8 minus 6 would give this. But we should remove this previous one, which was this 8 minus 3. So we removed that and we added 8 minus 6, which is this one, and our iterator is pointing to here, right? Upper bound of 6 is 8. It is pointing to here. As told, if we decrement the iterator, we get this. So we get here. So we subtract this 6 minus 3, we will get 3. So we added this 3, and also we added 2, which was from here 8 minus 6, right? This 8 minus 6, upper bound of 8, subtracting this upper bound of 6, which is 8. So we get this, and we added in this distance. Now, since we are using set, it won't allow us to store the multiple values, but I think we should need to store multiple same values. Why we need? Because if in the next scenario, let's say this 3 is 3 is this, right, this one, and the other one is this 3. These are two different unique distances. They have the same value, but they are two different distances. So if somehow, let's say, let's assume that a traffic light was added here, so this was going to break this distance, but this distance would remain, right? So we should use some set which stores the multiple values. And if you have watched my set videos, then you would have guessed we should use multiset. All this set, multiset, upper bound, I have the playlist of it. You can watch. You will get the link in the description. So same scenario, we will print the last element. We will display the last element, which is 3 in our case. This is the longest passage still without the traffic light. And we will add the 6 to our traffic lights. Okay, so let's add one more traffic light at position number 2. So the upper bound of 2 would be 3. So upper bound of 2 is 3, so our iterator is pointing over here. And as told, if we do iterator minus minus, we will reach over here. So clearly this has been broken down, the length. This has given rise to 2 new lengths. So now if I do, we should remove this length. So iterator is pointing over here, and iterator minus minus 0 is pointing over here. So we should erase this length. That would be 3 would be erased. Now this has given rise to 2 new lengths. We will add them. So first would be iterator is pointing over here, and the position is at 2. So 3 minus 2 would be 1. Other would be iterator minus minus. That means the second iterator is pointing at here 0. So 2 minus 0 would be 1. So this 1 and this 0. So 2 minus 0 is 2. So this will be added. And at the end, we will display the last element. Okay, so let's write the logic and the program of this traffic lights. So we need to have the street length, then the n sets of traffic light. Let's get it. X n. Now we need to have a container. So we should use set and let's call it traffic lights. This is the traffic lights and our distance. These two containers we need to have. And then other one should be multiset as told, of type int, and here it is the distance. And in the beginning, since there is we need to have start and end, so we will insert fiction traffic lights at position number 0 and the at position x, right? So we will have this, and also we need to have a distance. This is the max distance available before addition of any traffic lights. Now let's start. Is less than n and I less. Okay, so first we should grab the light For instance, here the light is at position number 3, so that would be provided. Let's create a light, and the light will be here. Now we should create, or we should do the upper bound of this light, which has been just inputted. Therefore, we will do traffic light dot upper bound of this light. So this would give us 8, and we should store this 8. So let's use the auto keyword, so we don't have to write the big line. Auto iterator, let's call this iterator, and this iterator is the iterator. So let's call this iterator. Iterator right. Let's call this iterator right. Now that means this would going to point. So 8 would be this, right? It means this. Now we should go to the left iterator also, means here. So I will say that I will create first the copy of iterator right, and let's call it iterator left. So we will call it iterator right. So we have created the copy. So left and right both are pointing here only. So but we need to point over here, right? So we'll say iterator left minus. That would make us to point here. Now we have this, and now we should erase this, right? Because addition of this created 2 new distances, so we should erase this. How we can find this? This max length 8, that is nothing but 8 minus 0, right? Wherever iterator right is pointing, iterator right is pointing over here, and wherever iterator left is pointing, over here. So if we subtract them, then we will get this 8, which has to be erased, right? Why we should erase? Because the addition of new traffic light gave us the new distances. Therefore, we will say we need to erase. So we will erase, and what we need to erase? We need to erase that element. So first we should find that element. So we'll say distance of find, and we will pass here the iterator right minus iterator left. We should pass the wherever the iterator right and left is pointing. So that is going to erase this 8. So 8 has been erased. Now we should insert these new distances which we have just seen. This 8 minus 3 is 5. So 8 minus 3, wherever iterator right is pointing, and the light which you have just inserted. So iterator right minus light, correct. So we'll insert now distance dot insert. What we need to insert? Light minus iterator right wherever it is pointing minus the light, right? Iterator right wherever it is pointing and the light. So that would give us 5. Okay. Also, wherever iterator left is pointing, that should be also subtracted, right? So light minus iterator left is pointing, that is going to give this distance, which is this 3 minus 0 is 2. So we should add this, insert this, the distance dot insert light minus iterator left is pointing. Now Also, we should add this new traffic light to our new traffic light container. So these is done here by these two lines. So we have inserted, we have removed, inserted. These two new distances has been inserted, and we should now add 3 over this traffic light. So I would say that traffic light dot insert light, and we should start here. Again, the content of the iterator where it is pointing, and at the end we should now display this, right, the last element of our set. How we can get the last element of our set? Very easy. We will just say that distance dot r begin. That gives the iterator from the end, reverse beginning, that we can say reverse beginning. How should the display would be? Okay, there should be space, not a new line. So I will give a line space, and yes, we should give the to get the content where the iterator is pointing, we should use star. If you have any issue in understanding of set, multi-set, iterator, all the videos have been posted on this channel. Do watch them. You will get the links in the description. So simple, right? We did the upper bound. Then since the new light will break the original gap, therefore we erase the original gap, and then inserted these two new lengths or distance formed by the addition of the traffic light, and then we added the traffic light itself in our container, and we displayed the last element of our container by using our begin. There is a reverse beginning. Great. Let's submit this now. Okay, so that is not the correct SNS, and here should be, here we should have traffic light color. Okay, that's all. Alright, that's it guys. Thank you for watching.